Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 12.2, Problem 4. This is Section 12.2, Problem number 4. We have a fairly big function, f of x equals 5x to the third minus 3x squared plus 2x plus 7 times 2x to the third minus 6x squared plus 11x plus 4. So, two parts. Part A, what is f prime of x? What is the derivative? And part B, what is f prime of x when x is negative 1? So, part A. F of x equals 5x to the third minus 3x squared plus 2x plus 7 times 2x to the third minus 6x squared plus 11x plus 4. Now, with this problem, you can find the derivative by using the product rule. This problem is a product. It's one thing times another. Now, if you don't mind enormous foiling problems, you could find the derivative without using the product rule. You could do out this gigantic FOIL that would involve all kinds of multiplications and simplifications and combining of like terms so that you have no more parentheses, and then you could just do the straight derivative. But it's much, much easier using the product rule. So this function is written as a product. So that's usually u and v. The first part of the product is represented by u. The second part of the product is represented by a v. And then we have f prime of x is u prime v plus uv prime, like that. And we'll fill that in, and that'll be the derivative without foiling. So f prime of x is, so the first piece is u prime. So u is the first set of parentheses, the 5x to the third minus 3x squared plus 2x plus 7. U prime will be the derivative of that. So the 5x to the third will be 15x to the second. And the reason for that, the exponent of 3 comes down times the number in front of 5. 3 times 5 makes a 15 in front. X to one less power, the third power drops down to a second power. The next piece, minus 3x squared, will become minus 6x to the first. And again, the reason for that is the exponent of 2 comes down times the number in front of minus 3 gives me my negative 6. X to one less power, second power drops down to a first power. Then the plus 2x that comes next becomes just plus 2, because when you have an x to the first, the derivative is just the number in front, the 2. Now the next piece, the 7 with no x, its derivative is 0. So I don't even need to write the 0. I'll close my parentheses. The next piece of the formula says just v. No prime, just v, the second set of parentheses. So I'll just copy them as is. 2x to the third minus 6x to the second plus 11x plus 4. That's v. Then I have a plus. Then I have u, no prime, just u, just the way it is. So the first set of parentheses with no change. So that is 5x to the third minus 3x to the second plus 2x plus 7. Right? That's the u, the first parentheses with no change. And the last part of the formula is v prime. V is the second set of parentheses. So v prime will be the derivative of the second set of parentheses. So the second set of parentheses starts with a 2x to the third. The derivative of that is 6x to the second. Again, the exponent of 3 comes down times the number in front, which is 2. 3 times 2, there's my 6. X, one less power, the third power drops to a second power. The next piece of the v is 6x to the second. So for the v prime, it'll be minus 12x to the first. And again, where that comes from, the exponent of 2 comes down times the number in front of negative 6. 2 times negative 6 is my minus 12. The exponent drops by 1 from a second power to a first power. The next piece of v is 11x, or 11x to the first. So the v prime will give me just an 11. Since I have an x to the first, the derivative is just the number in front, the 11. And the last piece of the v is just 4 with no x, so its derivative is 0. So it's really 11 plus 0, but I don't write the 0. And now that's the derivative. That will tell me the slope at any point I want. And the question for part B specifically asks, what is the value of f prime of x when x is negative 1? So I'll take my answer that I have, which could be simplified, but we don't have to. I can put in a negative 1 for x right now. Everywhere where I see an x, I'll replace it with a negative 1. I'll do the math and see what I get for an answer. So f prime of negative 1. So 15x squared is 15 times negative 1 squared. Negative 1 squared is positive 1, right? Negative 1 times negative 1, the negatives cancel. So I have positive 1 times the 15 in front is 15. And then the next piece of my derivative is minus 6x. So it becomes minus 6 times negative 1. Minus 6 times minus 1 is positive 6. And then I have a plus 2. So that's the first set of parentheses. The next set of parentheses starts with a negative 2x to the third. So if I put in a negative 1 for the x, negative 1 to the third is negative 1. It's negative 1 times negative 1 times negative 1. Odd amount of negatives, it stays negative. And you have the negative 1 that you get times the positive 2 in front. Negative 1 times positive 2 is negative 2. The next piece I have to put in a negative 1 for is minus 6x squared. So the x squared becomes a negative 1 squared, or negative 1 times negative 1. The negatives will cancel, giving me a positive 1, times the minus 6 in front. Positive 1 times minus 6 is negative 6. The next piece I have to put in a negative 1 for is 11x. 11x is really 11 times x, so it becomes 11 times negative 1. 11 times negative 1 is minus 11. And then there's a plus 4 in the end. So then I'll move to the middle part of my formula that has a plus. I'll just bring the plus down for now. And there's another set of parentheses where I'll put in a negative 1 wherever I see an x. So I have 5x cubed. So again, that'll become 5 times negative 1 cubed. Negative 1 cubed, or negative 1 to the third, is negative 1 times negative 1 times negative 1, which will be negative 1 times the 5 in front. Negative 1 times 5 is minus 5. And the next piece I put in a negative 1 for is negative 3x squared. So x squared becomes negative 1 squared. Negative 1 times negative 1 is positive 1. The negatives cancel. Positive 1 times the negative 3 in front is negative 3. The next piece I put in a negative 1 for is 2x. That's 2 times x. It becomes 2 times negative 1, which is minus 2. And finally, on the end, I have a 7. And that takes care of the third set of parentheses in my answer. There's one more set of parentheses. I'll put in a negative 1 everywhere I see an x. The 6x squared that it starts with becomes 6 negative 1 squared. So negative 1 squared is positive 1. Again, the negatives cancel. Positive 1 times the 6 in front is 6. Then the piece in the middle, I have negative 12x. That's really negative 12 times x. So negative 12 times negative 1 is positive 12. And then I have an 11 at the end. So now I can simplify a little further. Let me come back to the left. Have f prime of negative 1 equals. So the first set of parentheses I have in my answer is 15 plus 6 plus 2. 15 plus 6 is 21. 21 and 2 more is 23. Positive 23. Then there's another set of parentheses next to that. I have negative 2 minus 6 minus 11 plus 4. Negative 2 minus 6 is minus 8. Minus 8 minus 11 is minus 19. Minus 19 plus 4 is minus 15. Then I have a plus, which I'll just bring down for my answer. Then there's another set of parentheses, minus 5, minus 3, minus 2, plus 7. So minus 5 minus 3 is minus 8. Minus 8 minus 2 is minus 10. Then I have minus 10 plus 7. So negative 10, positive 7 is negative 3. And the last set of parentheses, 6 plus 12 plus 11. 6 plus 12 is 18. 18 plus 11 more is 29. So it's gotten better. So now I can multiply a couple of things. I'll have f prime of negative 1 equals 23 times negative 15. I'll use a calculator to help me out with this one. 23 times negative 15 is negative 345. And then I have negative 3 times 29. So negative 3 times 29 is negative 87. And to finally finish the problem to the end, I have negative 345 minus 87. So in the calculator, I get negative 432. So the value of f prime of x when x is negative 1 is negative 432.